Trigonometry, Chapter 4, Graphs of the Circular Functions, Section 2, Translations of the Graphs of Sine and Cosine, Video 2, Mixing Horizontal Translations and Period Changes. This series is based on content from Pearson's Trigonometry 12th edition by Lial, Hornsby, Schneider, and Daniels. In the previous video, we learned about the horizontal translations of the graph of f of x equals sine of x and f of x equals cosine of x. For c greater than 0, the graph of g of x equals sine of x minus c shifts the graph of f of x equals sine of x to the right c units, and the graph of g of x equals sine of x plus c shifts the graph of f of x equals sine of x to the left c units. The same applies to cosine. Just remember, subtract from the x, move to the right, add to the x, move to the left. In this video, we analyze what happens when we invoke both a change in period and a horizontal translation. For example, suppose f of x equals sine of 2x minus pi. What is the period? What is the horizontal shift? Well, we've discussed both of these already. Based on previous knowledge, we expect the period to be 2 pi over 2, the coefficient of the x, which is equal to pi, and the horizontal shift to be pi units to the right, since we're subtracting pi. But what does the graph say? Here's the graph of this function from Desmos. Does it have the period and horizontal shift we predicted? Well, the period does seem to be pi, since the difference in the least and greatest x coordinates is 3 pi over 2 minus pi over 2, which is 2 pi over 2, which is pi. So our analysis of the period was correct. However, the horizontal shift seems to be just pi over 2 to the right and not pi to the right as predicted. Remember, the graph of sine starts at the origin. So how can we extract the correct horizontal shift, pi over 2 to the right, from the function f of x equals sine of 2x minus pi? Well, notice that the ratio that expresses the horizontal shift contains two numbers that were in our function. So it seems to be obtained by dividing the number being subtracted by the coefficient of x. This actually makes sense, and here's why. The horizontal shift is the number being subtracted from x, but the pi is being subtracted from 2x. To rewrite this to show a number being subtracted from the x, we have to factor the 2 off of the x, but the pi doesn't have a 2 to factor out. That's an easy problem to fix. Watch this. We're going to make a 2 appear in front of the pi by first writing the pi as a fraction, as pi over 1, multiplying both sides of the fraction by 2, so now it's 2 pi over 2. And notice that both halves of the subtraction problem now have a factor of 2 that I can factor and put in front, leaving behind x minus pi over 2. Take 2 off of everything and leave behind x minus pi over 2. So this shows that the number being subtracted from the x is precisely pi over 2, which explains why this horizontal translation was pi over 2 and not pi. Now we're going to generalize this. But the rule of thumb is the number being subtracted from the x is going to invoke a horizontal translation. Now, how do we generalize this? Well, we can actually take one of two approaches. Number one, we can generalize for f of x equals sine of bx minus c. That's kind of the situation we had, where we had a number in front of the x and a number subtracted after that. So 2x minus pi, bx minus c. Well, we can factor out the b the same way we did before. It'll show up in front of a parentheses with x minus c over b inside the parentheses. So f of x equals sine of b times the quantity x minus c over b. And since c over b is being subtracted from the x, the horizontal shift is c over b to the right. Now, of course, if it said plus, then it would shift to the left. But sometimes you'll be given a function of this form. F of x equals sine of b times the quantity x minus c. In other words, sometimes you'll be given a function that looks like that, where there's a multiplier in front of x minus something or x plus something. So how do we generalize for that? Well, that one's easy. In this case, the c is being subtracted directly from the x and hence represents the horizontal shift to the right. Again, if it said plus, the shift would be to the left. Now, some functions will be given in the form f of x equals sine of bx minus c, in which case the horizontal shift is c over b. Other functions will be given in the form f of x equals sine of b times the quantity x minus c, in which case the horizontal shift is just c. You need to be familiar with both. Now, the consistent thing is that the horizontal shift to the right is always represented by the number being subtracted from the x. And of course, if it's added, then it's to the left. Now we're going to go backwards and find a function whose graph is given below. Let's analyze this for a second. What shape is it in terms of quarter period behavior? Where would that graph normally start? Which direction did it move? And what's the period? First, observe this is one cycle of cosine because it starts high. The period is the difference between the extreme x coordinates. So the difference between 15 pi over 4 and negative pi over 4 is 16 pi over 4, which is 4 pi. And because the period is 4 pi, then 2 pi over b is equal to 4 pi. Solve this and you get b equals 1/2. So our b is 1/2. The horizontal shift is pi over 4 to the left. And so the function is f of x equals cosine of 1/2 times the quantity x plus pi over 4. Remember, to the left is a plus. If we distributed the 1/2, we would have cosine of 1/2 x plus pi over 8. Now you try. Pause the video and try the following. All right, if you haven't paused the video and tried it yet, this is your fair warning. Solutions in 3, 2, and 1. The period of the first one is 2 pi over 3, and the horizontal shift is also 2 pi over 3 to the left. You would factor out the 3, plus moves it to the left. And for this function, the period ends up being 8 pi, because the difference in the x coordinates is 8 pi. And so 2 pi over b equals 8 pi implies that b is 1/4. The shift is to the right, pi over 2. So the function is f of x equals sine of 1/4 times the quantity x minus pi over 2. Forgot to mention it is a sine because it starts mid, and then goes mid, high, mid, low, mid.